Today's railways face increasing demands to reduce maintenance of way costs and to increase the gross tonnage that can be realized from each section of track. Heavier axle loadings due to expanded side coal and ore carriers and double-stack container traffic have increased the wear rate on all rail surfaces, but particularly the demands put on the weld zone itself. Weld batter and corrugation problems are now kept in check by preventative grinding programs. The Permatrack process was designed to head-harden continuous quarter-mile strings of new or used continuously welded rail to deliver a seamless weld-free section to the field by completely removing the heat-affected zone at the flash butt weld. Metal removal from the grinding process can be reduced an estimated 50% per grinding pass. Permatrack's fully computerized head-hardening process heats the complete rail section to a uniform austenite grain size, and then a controlled air quench develops a fine high-wear perlite structure in the rail head and high-toughness properties in the web and base. The Permatrack installation at Sydney Steel in Nova Scotia, Canada has run continuously, 3 shifts a day, 20 shifts per week, since commissioning in 1989. Rails treated by the process require no roller straightening and consistently meet AREA and UIC specifications in a high production capability. The result of 3 years of intensive research and development, the Permatrack process has proven that it can produce a deep head-hardened premium rail with the finest product characteristics available in today's market. The process involves heat-treating carbon and low-alloy rails to standard or deep hardness patterns, resulting in a fine perlite grain structure with highly desirable compressive residual stresses in the rail web. When new or used rail strings are processed, a significant benefit of the Permatrack process is that the compressive stress continues right through the weld zone. The Permatrack process is capable of producing 50,000 tons of heat-treated rail per year at a production speed of 5 feet per minute. This production rate can be increased by up to 3 times with additional power and quench modules. The process line has been designed to fit into the material handling process at the rail welding sites of the railways themselves. New welded strings comprised of standard carbon rail can be continuously heat treated to produce a seamless string of deep head-hardened 388 Brunel rail. Additionally, railways can now effectively recycle cascaded or used rail. After removal of defects, bolt holes, thermite welds, and other flaws by means of ultrasonic internal flaw detection, rehabilitated strings can be relaid and achieve an increased service life of 2 to 3 times. A major study commissioned by Illinois Central Railroad and completed in 1996 proved conclusively that the Permatrack process can recycle partly worn rail strings to a high degree of reconditioning. An average of 350 Brunel hardness with continuous compressive residual stresses was combined with a completely homogenized flash butt weld microstructure. In slow bend tests performed at the Civil Engineering Department of the University of Toronto, the load versus deflection curves indicate that the treated welds exhibit significantly higher strength and ductility over the untreated weld. The 4-point bend tests show an increase in load carrying capacity after heat treatment of 33% and an increase in ductility of 126%. This marked increase in ductility of the material indicates a major rejuvenation of the fatigue state of the used rail. The Permatrack process is a modern cantilever design with aircraft aluminum fabrication of heating coil and air quench modules. All critical components of the process are cooled by a deionized closed water system, including induction heating coils, conveyor drive rolls, and air compressors. The process requires only a light metal-clad building and foundation and is ideally suited to the location at the rail welding site. The process is powered by 3 Ajax magnethermic pacers, each rated at 1,000 kilowatts. These self-diagnostic, self-tuning variable frequency units ensure reliable operation, shift after shift, when linked with Allen Bradley programmable logic controls. 2 compressors are required for the process. The entire computer-operated process sequence can be monitored from the operator control panel. Different process parameters can be automatically preset for different weights or chemistries of rail. Continuously welded strings of new or used rail can be heat-treated in this mode, producing a uniform hardness pattern with compressive residual stresses through the weld zone. A complete string can be processed in 2 to 3 hours, and the equipment is designed to run 3 shifts per day, 7 days a week. The Permatrack process starts with the induction preheat coil, which rapidly heats the entire rail section to about 1000 degrees Fahrenheit or 538 degrees Celsius. As the rail enters the main heat section, top and bottom induction coils produce counterbalanced heating, which keeps the rail straight. Specially designed head-hardening coils raise rail temperature to the critical point necessary for achieving the fine pearlite grain structure characteristic of rails treated by the Permatrack process. This standard temperature graph, developed for 136 pounds per yard carbon steel rail, illustrates the capability of the Permatrack process to control temperature in the rail head, web, and base. This temperature uniformity and rapid cool down allow the treated quarter-mile string to be conveyed onto a waiting string train or onto storage racks at the welding site for later shipment. The Permatrack process is designed with flexibility in mind. Heating and air quenching modules can triple the production tonnages from 50 to 150,000 tons per year per single line. During periods when strings are not being processed, an automated loading table can be added to the process line to treat single rails. The Permatrack process. Innovative, cost-effective technology specifically designed to maximize your rail investment by increasing rail life and reducing maintenance of way costs for the 21st century.